LLM access, trust, and integrity debates. For users seeking access to state-of-the-art language models, the fundamental dilemma remains: fast, cheap, accurate, pick two. The local Llama community has become increasingly vocal about the murky waters of third-party model providers, whether the LLM served is unadulterated, over-quantized, or even quietly replaced. Stories abound of dubious actors, some name Atlas Cloud and Base 10 as cautionary tales, swapping to weaker or more aggressively quantized versions, or rate-limiting users right into lobotomized models without warning. Deep Infra, in contrast, emerges as a rare positive mention, noted for consistent quantization transparency and accuracy. Their FP4 claims 96.59% of baseline accuracy, but as always, the community urges independent verification. Yet, no provider is truly immune from perverse incentives. Profit and resource constraints often override user interests, especially outside of official, direct APIs. Quantization, reducing model precision, FP16 to INT8, Q4 down to Q1, saves memory and compute but degrades reasoning capabilities, and the degradation is famously nonlinear. Ultra-low-bit Q1 quantization is essentially worthless for anything serious, while Q4 is commonly cited as an acceptable baseline with only marginal quality loss, if you trust the vendor. Still, periodic benchmarking and quality checks are not a luxury, but a requirement, since silent model swaps are routine. Open-source verification tools, like MoonshotAI's K2 vendor verifier, address some integrity issues for specific models, but comprehensive provenance remains elusive. Ultimately, for those uncomfortable with ceding trust, self-hosting is ideal, though hardware cost and complexity make this out of reach for most individuals. Further complicating matters is user privacy. Anyone using third-party APIs can be subject to prompt scraping or outright data leaks, not just from rogue employees, but official providers eager to boost margins by running off-quality model variants. The pragmatic advice: never enter confidential data and keep constant tabs on provider performance. OpenRouter's ability to blacklist or track provider endpoints is an example of minor mitigation, but not a full solution. As the prospect of model provider accountability and perhaps regulation looms on the horizon, the ecosystem continues to rely on a mix of vigilance, benchmarking, and a healthy dose of skepticism to obtain trustworthy AI. Extreme local LM hardware and DIY training. The ongoing debate about LLM provider trust has reignited interest in local inference hardware, with some users investing in near-absurd dream stations. A recent build log provides a window into the top end of consumer-accessible LLM hardware. Threadripper Pro 7995WX CPUs, Asus motherboards with 7 PCIe 5.0 x 16 slots, 4 RTX 6000 ADA GPUs, each with 96 GB VRAM, dual 1650-watt power supplies, 512 GB of DDR5 ECC RAM, and NVMe RAID 0 setups capable of streaming hundreds of GBs for model loading. Yet, even among elite hardware circles, there's nuanced debate over cooling, blower, Max-Q versus axial workstation cards, PCIe bottlenecks, RAM over-provisioning, and the management of multi-thousand-watt heat output in residential rooms. A giant electric heater effect, as one builder puts it. Despite the intimidating cost, often north of $30,000, the motivation is clear. Total control over what model runs, how it's quantized, and what data stays private. For those undeterred by price tags, these mega-rigs promise the ability to run multiple state-of-the-art models concurrently, batch process massive inference loads, or even train smaller-scale models from scratch. For practical users, the learning curve in physical realities, power delivery, case airflow, software stack tuning, are non-trivial, and creative solutions like dual PSUs and 220-volt welders turned data center circuit are not uncommon. But the narrative doesn't stop at big iron. The open-source community continues to lower the hardware bar for local LLM experimentation. Fully local AI agents now run on hardware as humble as a Raspberry Pi, albeit slowly. With enough patience, a wake-word-triggered voice assistant running an LLM, speech-to-text, and text-to-speech workflow, all offline and open source, isn't just possible, it's almost practical for hobbyists. Building, fine-tuning, and evaluating LLMs and MLLMs. Against the backdrop of both hardware enthusiasts and API skeptics, the open-source LLM ecosystem is flourishing with hands-on educational projects and new learning paradigms. A recent blog series demystifies the process of building LLMs from scratch. No fine-tuning, just raw tokenization, pre-processing over 500 million characters from London's historical texts, and multi-GPU training on consumer hardware. The models themselves, 170 EM and 354 M parameters, are educational toy models, serving as reproducible guides rather than production-ready tools. Critics in the thread highlight the distinction. While documentation and openness are essential, autofilled docs, missing citations, or any hint of plagiarism erode trust. An open-source project's reputation depends on both code quality and attribution. One practical insight: LLM smartness scales not just with model size, but with dataset diversity and size. Community discussion details how, with aggressive filtering or synthetic data, even small models can punch above their weight in authenticity or period accuracy, offering a blueprint for new researchers, hobbyists, and students. Fine-tuning isn't exclusive to text models. Open-weight diffusion LLMs like Lada and Dream now have their own open-source, lightweight fine-tuning toolkits. The new DLLM framework integrates with Hugging Face transformers, supporting deep speed, multi-node configs, quantization, LoRa, and more, signaling growing accessibility for researchers seeking to adapt generative diffusion models to custom workloads. Openly available multimodal LLMs, MLLMs, are stretching the boundaries further. The newly released R4B model is a standout in auto-thinking, automatically switching between stepwise reasoning and fast single-answer modes for visual question answering and multimodal reasoning. With full support for VLLM and 3 explicit control modes, auto-thinking, thinking, non-thinking, the model delivers top-ranked performance, especially for users who want to balance compute budgets with answer quality and consistency. Manual override gives users direct agency, while its 2-stage training paradigm mixes deep reasoning with fast, shallow response capabilities, tackling the age-old MLLM challenge: how to optimize both accuracy and inference efficiency with one model. Novel LLM reinforcement learning, rubric anchors, and reward shaping. The area of LLM training, especially reward tuning, is undergoing a revolution beyond the classic RLHF with human feedback, or RLVR, reinforcement learning from verifiable rewards restricted to coding and math. The new Rubicon framework demonstrates a leap: large-scale structured rubrics, essentially multi-dimensional, human-crafted evaluation guides, now anchor reward signals for open-ended subjective domains like humanities, creative writing, or nuanced agentic tasks. Rubicon is not just a research curiosity. Empirical studies using Qwen30B Rubicon Preview show that with just 5,000 training examples, but over 10,000 rubrics, a 30B model can outperform competitors 22 times its size, e.g. DeepSeek v3 671b, in open-ended benchmarks, plus 2.4%, with little to no loss in reasoning or STEM accuracy. The secret sauce isn't simply more data, but the scaling law of rubric diversity. More nuanced, granulated, and multidimensional reward signals create more controllable, human-like outputs, less AI-like and more emotionally expressive. This paradigm shift could mark a post-training scaling law, that the right rubrics, not just more data tokens, can drive leaps in language model capability and alignment. Yet pitfalls abound. Researchers warn of reward hacking, over-optimizing to the rubric's explicit criteria at the cost of true performance, and teaching the LLM to game the rules. Ablation and diversity are still open research questions, but the impact is clear. Rubric-anchored RL opens creative and subjective domains to systematic post-training for the first time. Model and agent evaluation, domain-specific benchmarks and life cycles. Evaluation, fine-grained and domain-specific, is the next frontier. PHM Bench, a new 3-dimensional benchmark suite, is built for prognostics and health management, PHM, a complex field involving equipment health, predictive maintenance, failure diagnosis, and lifecycle optimization in industrial settings. PHM Bench is remarkable for its methodology. Instead of focusing only on final performance metrics, it incorporates foundational knowledge, task-specific reasoning, and even system design and lifecycle considerations. In head-to-head evaluations, general LLMs perform admirably on knowledge retrieval, but falter on nuanced diagnostic or condition monitoring tasks compared to domain-specific models. The new benchmark's significance lies in exposing not just what a model can do, but where and why, specialized fine-tuning provides a necessary boost, especially for safety-critical applications. The granular, reproducible nature of PHM Bench is a model for other scientific and industrial domains seeking rigorous, actionable model evaluation. Model deployment, speed and optimization for Mac and beyond. The hardware-software interface is gaining fresh attention, especially for those running LLMs locally on Apple Silicon. Projects like MetalQuinn 3 take inspiration from minimal C-based inference engines to deliver full transformer model inference on Mac's GPU, leveraging metal shaders for truly local, fast, 75 tokens per sec on an M1 Max, a 2x speedup on CPU operation. These platforms are not substitutes for VLLM or Llama.cpp on cloud supercomputers, but educational tools and point solutions for consumer devices, promoting true user control and on-device privacy. Similarly, in the speech and audio domain, new open-source tools like Handy, speech-to-text in Rust, AMIDI, trainable MIDI composition with GPT-style models, and research releases like Index TTS2 and UniAudio 2.0 are making multitask, expressive, and privacy-preserving AI audio workflows practical at home or on personal hardware. On the infrastructure level, advances like Slide.io demonstrate that storage bottlenecks, traditionally a limiting factor for large model or high-throughput inference, are being addressed via cloud-native, high-performance block storage, ready to keep up with even the fastest inference stacks. AI coding assistance and context window advances. For software developers, coding copilot tools are making rapid strides. RuCode's new 3.28.6 release introduces GPT-5 codecs with a jaw-dropping 400,000 token context window, improving full project context for refactoring and review. Native function calling, enhanced code understanding, and efficient API token usage further optimize the developer experience. While some users debate the bug and compatibility status versus regular GPT-5 and how codex's output briefness and stuck states differ, the consensus is that coding specialized LLMs are closing the gap on full developer project assistance. Competition is heating up in alternative copilot agents, some using Claude to double-check codex's output, especially to avoid gaslighting and factual errors. And under the hood, compatibility with MCP, Model Context Protocol, is a key requirement for seamless function calling and integration in modern code assist workflows. Questions remain around open web UI integration. For example, handling output formatting quirks, such as LLMs spraying raw HTML tags into markdown tables, and practical workflows for embedding images alongside text in chat or RAG, retrieval augmented generation queries. Increasingly, practical tooling via CRXNG, Dockling, and local search indexers supports a seamless move from text-only outputs to richly formatted multimodal LLM answers optimized for developer needs. Internet search, agent tools, and APIs. The AI tooling landscape now leans on live internet search just as much as model weights and architecture. End users and tinkerers are piecing together setups where models, Llama, OpenWebUI, leverage built-in or CRXNG-powered online search for retrieval augmented answers, boosting response quality with real-time data. MCPO, the new Model Context Protocol, further speeds up online queries and local agents, reducing both token usage and latency. Meanwhile, the search giants are opening up their infrastructure. Perplexity's new Search API, previously powering internal AI answers, now offers public developer access to a global-scale search index with rich, granular, sub-document indexing for maximum RAG utility and complete with an open evaluation framework. This brings a credible, highly factual search retrieval layer to LLM and agent developers eager to move beyond either slow, costly Google custom search APIs or insular proprietary indices. Unsurprisingly, security and provenance are growing priorities. AWS's general availability of EC2 instance attestation, leveraging Nitro TPM and cryptographically measured AMIs, allows for ironclad verification, ensuring even GPU and AI accelerator instances are provably running trusted images. This raises the standard for cloud-based LLM deployment, key management, and supply chain integrity in critical or regulated environments. With the application and infrastructure landscape moving this fast, the need for reliable, reproducible benchmarks, robust provenance, granular agent control, and privacy-preserving local options has never been greater. The tension between openness, control, deployment cost, and trustworthiness will continue to shape the AI landscape as both research and practical deployment accelerate through 2025.